Yeah, it's raining. It's bad. When it rains like this, usually the office gets freezing cold. Hey, everybody. Is there any chance that someone in the room would be able to tell me if you could hear me? Could you hear me, Jorge? No, I don't hear you. You're muted, right? Yeah, okay.
Check, check, testing, testing, 1, 2, 3.
Sounds good, man. So I'm just checking our YouTube channel to see if our friends are gonna have some friends joining us soon. So those that are participating, I'd like to thank you for joining us. My name is Edwin Robledo, and Jorge will be driving today's webinar. The topic today is going to be about the Autorouter. Autorouter has multiple aspects to it, and having an understanding how it relates between the design rule checks and the Autorouter is always it's always good to know. Also, just to let you know that it does also take into consideration the values that you set up on net classes. And net classes are the values that you could assign to a particular class, which could be assigned to the signals on your schematic or on the board. So we're going to be reviewing that for 30 minutes today. So let's give it a couple more minutes. We have 2 more minutes before we actually begin. Those that are joining us on YouTube, as well as the ones joining us on live on our webinar platform, always like to know where you guys are located. Like to know where you're from. Are you in the US, Latin America, Europe, Asia? Just to let you know, Jorge and myself, we're here located yes, east from Fort Lauderdale and just north of Miami. So we're right there in that in the middle spot there. And today, wow, you could barely see outside how hard it's raining today. Oh my God. It's raining really hard over here in South Florida. Okay, so give it a few more minutes before we actually begin. Lightning and thundering. Oh my. Okay, excellent. So I think it's a good time. We're around 2 minutes past. So those join us on our YouTube channel, thank you very much. Greatly appreciated that you have decided to join on this webinar. If you don't mind, we'd like to know where you're located in the world. Always like to find out where our friends that are joining on these webinars are located. Okay, the room is getting filled all of a sudden.
Yeah, and that goes for everyone on YouTube too. Feel free to let us know where you're joining us from.
Absolutely, sure thing. Yeah. So yeah, the room is getting kind of packed on YouTube as well.
Oh, we got somebody close, Orlando.
Oh, right up the street from us. Excellent.
If a 4 hour drive is right up the street, then yes.
Well, compared to to India or something like that, so a little closer. So yeah, got friends from Canada, from New York. New York. Last year, I had the opportunity to visit the hackerspace called New York Resistor. Very, very, very nice group. They got all sorts of equipment. Incredible. Nice place. Oh, just to let you know, Jim, we're over here in Fort Lauderdale, so we're pretty close. Okay, I think we're just gonna go ahead and begin the presentation. Well, my name is Edwin Robledo, and Jorge Garcia. We're both part of the Autodesk support team. We mainly specialize on presentations that have to do with Eagle. And yes, yesterday we actually did a really nice one between Eagle and Fusion 360 and the workflow that we have for that. But today we wanted to concentrate on the Autorouter. Autorouter is a great tool if you use it correctly, but you should really primarily be working on your when you're converting your connections that came from the schematic over to your board. You should really consider always using the manual routing features because there's no way you're going to get an Autorouter to give you the same results. I know it's a lot more work. Now, if you need to do a quick spin and you want to use the Autorouter because there's just nothing all that critical on the board that you could just pull it off. Let's say if it's all digital, for example, then there are instances in which yes, using the auto router, yes, maybe pull it off. But when it comes to final products, we strongly recommend that you always use the manual routing, in which we've covered. Didn't we just cover that one recently? I think it was the manual routing. We just recently covered that one.
Yep. I think
But
maybe
today,
two webinars ago. Two
yeah,
three
so
webinars ago.
today we just want to cover about using the auto router, but we're just going to use it as an additional tool, not the primary tool of converting it. So, and there's multiple facets to the auto router and how it could be used. So I'm going to stop sharing my screen. That way we could go over to Jorge's screen. Now we're going to have a Q&A session at the end. Okay, so our friends on YouTube, as well as our friends that are joining us on our platform, go ahead and just hang on to your questions, or if you want to post your questions throughout the presentation, that's okay too. It's just we'll address them at the end. And the reason we're doing it this way is because it's just it flows a little faster, and the recording is just that much nicer for our friends which want to enjoy the recording later on. Okay, so Jorge, it's up to you now.
Let's do it. Sharing my screen. Okay, let me know if you can see it.
Not yet. Yes, we do see it now, Jorge.
Okay, nice. So what we're going to do today is we have this really nicely routed demo board that ships with Eagle. And the first thing we're going to do is completely trash the routing. So let's start there. We're going to rip everything up. Yes. Okay. So let's talk about a few things that are unique to Eagle's Autorouter and that are really going to help you leverage it effectively. So first thing we want to do is set expectations. Okay, if you are counting on the Autorouter to do everything for you perfectly, then you are going to be sorely disappointed. Remember that the Autorouter is a tool to be leveraged depending on the situation. You know, if you have a hammer, you have a wrench, you have a saw, you don't use the hammer for everything. You don't use the wrench for everything. So you need to know when a tool applies. And the same goes for the Autorouter. The Autorouter can be very helpful. It can save you a lot of tedious work, but you can't just let it loose on a layout and expect a result that's going to be functional, especially if you have a design that has any type of non-trivial requirement. So if you have something like an Arduino you can probably auto router and everything's going to be fine. But now if you start dealing with high power, high current, If you have sensitive signals, if you're doing anything medical, if you're doing anything with related to RF in any way, shape, or form, Wi-Fi, Internet of Things, if you're doing USB, especially the 2.0 and 3.0 standards of that protocol. So, anything like that, the Autorouter is just not the tool to do it. Now, the way you can use it, even if you do have critical traces in your design, or rather, let me back up. The first thing you want to do is determine what traces in your design are critical. In other words, which traces in your design have to be routed carefully. And you want to do those first. So anything that, like I mentioned, high current, high power, high speed, low level signals, anything that's very sensitive, those traces have to be routed manually first. Okay, and the reason for that is that the autorouter will not modify anything that's already routed at the time that it starts to run. In other words, if you do all the important traces manually first, when you run the autorouter is not going to touch anything that you routed manually. It's going to leave it alone, exactly as you left it. So what you can do is route those careful traces and then let the autorouter finish the stuff that is trivial, the stuff that it's not critical how it's routed. And in that way, you save time. You're not fully manually routing the board. You're manually routing the important parts, and then you let the autorouter finish what's left. And that's a net time savings versus manually routing the whole board. So that's one way you can leverage it to save time. So let's go ahead and show how the autorouter works. Okay, so first thing I'm going to do is actually I'm going to manually route a couple of traces just so that we have something we can verify that the autorouter didn't modify. So I'm going to go over here to the route mode. Actually use quick route signal for this. Let's route this one. Okay, and let's route this one, see what happens. Okay, so we want to remember P6 here and P3.4. So P3.4, P6.0. Let's remember that. We want to remember what these traces look like so that we can confirm that the autorouter did not modify them in any way, shape, or form. Now, is this the optimal way to route these traces? Is this the best way? Probably not, especially taking into account what other traces may need in this design. But just as an example, we want to remember that 6.0 and 3.4 were routed prior to running the autorouter. Okay, we want to remember that. So now what we're going to do is we're going to click on the autorouter icon.
You don't see this, but he's writing on his whiteboard. That way he can remember.
I don't want to forget. Okay, so the autorouter setup is actually very straightforward, but let's go ahead and explain some of the functionality here. So depending on your type of license, if you have a premium, it'll show all 16 layers. If you're on free, it'll show 2 layers. And if you're on standard, it'll show the maximum of 6, okay, of the 6 layers. Now the layers are always shown from the outside surface towards the middle. So if you had a standard version, it would be 1, 2, 3, 14, 15, and 16. But since we have a premium here, we have all 16 layers. Now notice that this is a 2-layer board, so only the top layer and the bottom layer have a preferred direction defined. Everything else, because we're not using those layers, is set up as not applicable. Now, I like to usually equate the autorouter to being similar to a dog. You can guide a dog, you can give it orders, but you can't force it to do something, at least, not without being extremely cruel. But in the case of the autorouter, it's similar. You can guide the autorouter, you can adjust cost factors, you can set certain preferred directions, as you can see here, preferred. That doesn't mean it's going to only stick to those directions. What it means is it's going to do its best to stick to them, but if it needs to, it's going to deviate. So keep that in mind. When working with the autorouter, you can guide it. You don't have really strict guarantees on anything, except in a few very rare occasions. But most of the time, you're just given a preference. You're giving the autorouter, I'd like it to go this way. And then the autorouter is going to be like, okay, I'll try, but if it doesn't work, I'm going to do whatever it takes to make it fit, to make it route. So one thing we want to talk about, if you notice, the directions are pretty clear. You have left to right, which is a dash, up down, which is this vertical bar. Forward slash is favoring diagonals, going from bottom left to top right. Backslash is going from top left to bottom right. Asterisk means you don't care, you don't have a preferred direction at all. NA means the layer is not available for routing. And then auto is special. Auto basically tells Eagle, you pick. You set my preferred directions. Now, usually by default, we're going to have auto. Now, why do we have auto? Well, it's going to come down to this over here. You see this parameter called effort, and it has 3 settings, low, medium, or high. The way the Eagle Autorouter works is that it sets up multiple runs of the autorouter, multiple instances. They're all configured slightly differently, and then lets them run. At the end of this, because they're all running at the same time, you're going to end up with several possible routes, several possible routing arrangements in your board. And you can review them and pick the one you like best out of the ones that get generated. Okay? That's why auto can be important. Auto allows Eagle the flexibility to adjust preferred directions in those routing variants. So if it generates 5, let's say 5 runs of the autorouter, 5 routing variants, if you have top and bottom set to auto, they'll all be different. Whereas if you actually specify something like this, they're all going to have the same routing directions. So they're all going to be for the top layer up and down, bottom layer left to right, but then other parameters will vary. So to get the maximum amount of variation, you want to set it to auto. Okay. Now effort, as you can see, low, medium, or high, very fuzzy what low, medium, and high actually means. Basically, what Eagle will do is it'll analyze your design, and then if the effort is low, it'll generate maybe 3 to 6 routing variations. If the effort is medium, 6 to 12, 13, maybe a bit more. And then if you have it high, I've seen high go as many as 23 variants, I think is the most I've seen. But basically, that's what it means. It's basically determining how many variants you want to kind of analyze, how wide you want to cast the net, per se. For a board like this, I typically like low. But if you want to have lots of options, feel free to set it to high. The more effort, the more time. And that's pretty natural to understand, right? The more you have to work on something, the longer it's going to take to do it. Auto grid selection. So grid is a parameter that has a huge impact on routing, especially with the old auto routing algorithm. Basically, the lower the grid, the more possibilities for routing to get done. Also, the more time the route job would take. By setting it to auto, again, you're giving Eagle the ability to vary that parameter among the different routing variants. So usually variants that have finer routing grids get more done, typically, but they take longer to run. So that's the trade-off. Variant with top router. So for many years, Eagle had one auto routing algorithm. It was very brute force. It would basically route until it couldn't route anymore. If it couldn't route anymore, it would pull back the last few segments, which you could determine, and then go off in another direction and repeat this multiple times until it really couldn't route anymore. It is very brute force, but it's also very fast. So I think, what was it, Ed? Like 3 years ago, 2.5, we introduced the top router. A little longer than that, so maybe 4 years for the top router. So for the top router, basically is a more intelligent algorithm. It actually uses sophisticated maths, namely Voronoi diagrams, to break apart the design and kind of determine these optimum paths where routing should happen. It makes like a mini sketch. It passes that along to the old auto router, which then uses it as a basis to form the routes to do the auto routing. In general, the result tends to be aesthetically a little bit nicer. It's a very subjective thing, but that's been my experience. Additionally, it tends to produce fewer vias. The downside is that because it is an intelligent algorithm, it does take considerably more time to run. So if you have a large design, it can take a good while to run. So if you need to get something in a hurry, it's usually a good idea to uncheck this, because the top router is going to take substantially more time to run than the old algorithm. But we'll leave it here for this example. The last option here is the maximum number of running threads. Basically, for every core available on your machine, you can have 2 threads. So my machine is 4 cores. I can have 8 threads running at once. Okay? And I think Eagle actually tops out at 8. I've never seen one with more than 8. Yeah. So this basically means how many runs can be processed simultaneously on your computer, because the Autorouter in Eagle is currently the only part of Eagle that can leverage a multi-core processor. So it will run 8 runs consecutively. Sorry, not consecutive, concurrently.
I don't see any other reason for anything else to really do it, because this is the maybe the most number crunching process of
Correct. It'd be
in the
awesome if other
PCB
parts
design.
could do it, but yeah, this is the one that can. So from here, we click continue. You can also load previous configuration if you wish. So go to continue, and you'll see that with that effort low, it generated 5 variants. Whenever you have variant with top router, the first one is the one that runs with top router. The other ones don't. Now you're going to notice that our original traces are there. The polygons have filled. So it's Eagle cleaning up and making sure that the autorouter only routes what's necessary. That's also why you see that this is a non-zero percentage, because we have the polygon making some connections, and we have our 2 traces that have made some connections as well. So we actually have control over the parameters of each of these variants. So Eagle has already made them all different, but we can go in and make other changes. So if I pick one and I press here, you're going to see that it grows. And you can see the parameters that have been defined. You can see what the actual preferred direction are for this one, for this variant. It's left to right, up, down. Routing grid is 12.5 mils, the via shape. You can go to buses. Now here's where that element of uh, of guiding the auto router and not being able to force it comes into play. In the Eagle manual, you'll find all these cost factors delineated. We'll go over some of them here as we play with them. When you look at this first tab, buses, okay, it's not buses in the schematic sense where it's a collection of nets. Here, what this tab does is it basically is the first pass. So they run consecutively from left to right. And what it does is it does everything it can to try to obey the preferred directions. That's why you see an increased cost factor for layers that are not active. Top and bottom are 0. And you'll see that anything that changing a direction, for example, going in a non-preferred direction, is expensive. Okay? So Eagle is going to try to avoid expensive operations. So for example, adding a via is expensive. So it's going to do everything it can to avoid adding a via. If there's another route that's less expensive, in other words, has less weight to it, then that's what Eagle's going to do. Okay? So as you can see, changing direction, not too bad. An orthogonal step stays the same. The impact of running into these different types of items, extended steps. You can put in the maximum number of segments, extended steps that go in. So extended steps are basically after coming back, how much further it can go in other directions. You see, there's no limit to the number of segments that can be used. If you go to route, you'll notice certain things have changed compared to buses. You can limit the number of vias per net, number of segments, rip up level, rip up steps, rip up total. So basically this rip up level is how many segments when it crashes and it can't route anymore, how far back it goes. It goes back 10 steps. And then in a given net, what's the maximum number of times you want, the maximum number of steps you want it to do? Because some nets are big. For example, ground nets cover your entire board. So you can see there's a lot to play with here. But the main idea to understand is the larger the value in any of these fields, the more unlikely that action becomes. So if you want to minimize the number of vias, you set via to a high value. And that makes the Autorouter really not want to put vias. But again, if it has no choice, it will drop that via. So you don't have a hard guarantee that it won't drop the via. And we can add multiple runs of these. You'll notice in the top router there are runs to clean. So if we go to top router, you'll see we have the same buses, we have route. You see how expensive route makes vias. You can see here. And then you have these optimized runs. And the idea of the optimized runs is to go multiple times trying to clean up and minimize the number of vias. And they're all set up this way. So if you notice here for top router, no preferred direction, a really fine routing grid. Variation 2, up, down, left, right, 25 mils. Left, right, up, down, 25 mils. Up, down, left, right, 12 and a half. Left, right, up, down, 12 and a half. So after, and you can obviously add, you can duplicate, you can make changes. But in doing so, you see that you're going to get different routing results for all of these. So what I'm going to do is I'm going to press start and let's see what happens. Now observe, all of these, the other ones are routing super fast, but the top router hasn't even started yet. You see, these finished already. These are complete. They did as much as they could.
You gotta be patient. When you want the really good results, you just gotta hang on. Actually, it's pretty fast for 31%, actually.
Well, 31% is what it had before we started, but now it's going. And you'll see it'll do some weird, funky looking things. Don't sweat it. At the end, once it's done, it cleans everything up.
It's topological, remember.
I don't think we said what topological means.
I'll let you give that a shot.
So basically, topological means it's not grid-based. The first autorouters would basically take the work area, break it up into a grid, and all the traces would follow along the grid. A topological router isn't limited to a grid. Hence, it can make weird and more natural looking shapes.
Yeah, so it's like trying to follow like a contour-ish type of...
And as you can see here, it's actually achieved quite a bit more than the other runs have. But it's also taken more time to start getting active. Now, if you want to inspect the other ones while this one's routing, you can actually move and you can see what they ended up doing. Now, while it's running, you want to let the Autorouter run to completion. So if you see it says running, it hasn't completed yet. It's still running. So we want to let it run until completion. In general, it's not a good idea to interrupt it, especially while it's running the top router. You can get Eagle into an indeterminate state. So you want to let it run until it finishes. Doesn't mean Eagle can't recover. Sometimes you can stop a route halfway or something and it'll be fine, but it's generally not good practice to do that. You can see the number of vias that have been generated. Right now, like I mentioned, it tends to do less than the old algorithm as far as the number of vias. And at the bottom, you can see the progress of the connections, how many it's traversed, how many it's tried. It's trying to do connection 288 out of 292. So we're getting there. And you can also see why it's worthwhile to have the top router if you have some time, because you can get further along than sometimes the old Autorouter algorithm would. If you're not going to do the top router, then my suggestion is set it to a higher effort level. That way you get more variations, and you'll be able to get more options at the end of the Autorouter running.
There'll be instances that you don't want the topological router because you see straight through buses or something like that. So it's common to just turn them off because remember, when you want to use the auto router, you could either have it do the entire board or you could just select what signals you want to route. And there will be instances that you want to use the auto router multiple times. So you will only select certain signals. Let's say you want something that's just straight through and you don't want to use a quick route. So you could select those and turn off the topological router because it's just a quick run and you don't really and the space you have may just be single sided. So you don't have to worry about it. That way you just get faster results.
Yep. So now it completed, as you can see. Completed, optimized for, went through all the routes. So we have these 5 results right now. Now we can go along and inspect them individually. So let's say, for example, I want to evaluate this one, see how it came out. I click evaluate, zoom in and out. I can rat's nest, make sure the polygon is clean and up to date. As you can see, it routed almost everything. There's things it wasn't able to route. And the end result, in many cases, looks pretty sensible. As you can see, you still get some funky curves going on like this thing. It would still probably need some cleanup. You can definitely tell it wasn't done by a person. Lots of just angles that go off in different directions and things. But overall, the result is usable. Okay, but it wasn't able to run 100%. Now, one thing that's common and happens a lot, a user will click evaluate, and then they'll think that that's it, that the autorouter is done, and they'll start changing this and they'll continue working. And what's going to happen is, because they never hit end job, the autorouter is always is basically on standby, waiting for you to either accept the routing result that it gave or to go back and evaluate another one. And as you start making changes, you start deviating from what the autorouter had before. And eventually it gets to a point where Eagle can't reconcile the two. So a very key important point with working with the autorouter is that you must hit end job at some point. You have to hit end job. So let's do this. Let's go ahead and show you how you can do this. So right now, let's say we're happy, we got whatever we wanted to see out of this, and we want to evaluate another route. What you do is you see this icon over here, says Autorouter job pending. Left click it. You'll see it'll tell you there's data available from the recent Autorouter job. If you want to continue to evaluate changes, in the current drawing will be lost. So if you've made any changes, those will be lost. Otherwise, you can fix the current board and end the job. So I want to evaluate. I want to check out the other routes. So you click evaluate, and now you can pick another one. Let's say this one. You say evaluate. You can see this one obviously was not able to get as far. Results are not as nice compared to the topological autorouter, but still would probably be usable.
How do you switch from one job to the other?
Yeah, I did.
How is that you switch from one job to the other job, Jorge?
Yeah, you go again. If you're evaluating, you see down here you have this icon. You left click it, you'll get that. You click evaluate, and you can see the ones that were run. So I can pick this one, hit evaluate, zoom in, inspect it, see if I like it. Okay. Now in this case, it's very obvious which one we should keep if we're going to keep any of them. And take a look here. You can see that our traces, the two that we did in the beginning, 6.0, not tampered with, right there. 3.4 goes through, not tampered with. Okay, so that's the key to getting the most out of the autorouter. Anything that's critical, hand route it first, then let the autorouter go to town on what's left. So now, let's go ahead and pick one to keep. I'll click evaluate because I want the top router result. I want to keep that one. I hit end job, and now we can continue to make changes and work on the board. Okay, so key point, you must hit end job some point when working with the autorouter. Okay, you have to. Otherwise, what's going to happen is you're going to get to a point where Eagle can't sync the two anymore.
Yeah, and and when you get to that point, it gets really scary. It's not easy to recover from it.
So you do want to avoid it if you can. So a couple of things. What can we do with the autorouter and the cost factors? Well, again, like I mentioned, you can guide the Autorouter if you want to try to stick to one layer, basically make the cost factor of the other layer super, super high so that the Autorouter won't want to get involved, won't want to switch to the other layer. And you can see what the cost factors represent. So if we go to documentation, you go into Eagle Manual. This is one of the things that I thought was one of the best things in our manual, or is one of the best things in our manual. Come on. Chapter 7. Where are we? Here we go, 7.6. Give Adobe a second to catch up. There we go. So it tells you values between 0 and 99 are possible for each cost factor, but it gives you suggested ranges. So if you look, base 0 to 20, VIA controls the use of VIA 0 to 99, controls following the preferred direction. Low value allows tracks to be routed against the preferred direction. High value forces them into the preferred direction. So you'll get little tips like this. If you set it to 99, then the tracks will only be placed in the preferred direction. How expensive it is to change direction. These you generally don't want to mess with. It'll explain here. Parameters should be altered with great care. It basically is a cost factor of how much it is to move orthogonally versus diagonally. And it uses a hypotenuse of a right angle triangle to make that determination. Safest thing to say is just leave it alone. Extended step, avoidance of track sections which run at an angle of 45 degrees. And you can see how all these different parameters can be set. This is very well detailed. All the different cost factors are here. What values are recommended, what range of values.
Now, the values that come with Eagle are pretty safe and usually pretty good. So you don't really need to mess with this unless it's very specific.
Correct.
Yeah, because even though they're conservative values, the ones that we're using, they pretty much apply to a lot of scenarios.
Correct. And then here you have the explanations for the maximum values. How the RIP parameters are, which are described here. Very detailed. The Chapter 7 of the Eagle Manual covers in detail how all of the different cost factors work and how they interact with each other. So it's a good read if you really want to leverage the Autorouter. Now, what were some of the things that we do with the Autorouter? What are some of the things that may require changing the cost factor? Well, if we go to the end of this chapter, you're going to see some practical hints. Okay, and here's where cost factors and things like that are useful. The first thing to note, Autorouter cannot set arcs and it can't set microvias. Okay, cannot do that. So here you see some tips on getting single-sided boards, for example, how you can change SMD boards to supply layers. This workflow is no longer necessary because of another tool that was added in the newer versions of Eagle. If you're working with an old version of Eagle, then you will need to do this. If you want to do drops to a ground plane or something like that, you will have to use this tip here. But in newer versions of Eagle, you don't really have to worry about it. There's another command that can do the job without you having to tamper with cost factors. So if we look, what can we do? What can we leverage now as far as the new tools? So this is the Autorouter, like we mentioned, but there's another Autorouter in Eagle that's worth talking about. So let me go ahead and rip up the polygon so we can see the routing. And that's this command over here called fan out. Okay, this is a type of Autorouter as well. And to use it, what I'm going to do actually is I'm going to rip everything up again so we can highlight how it works. Okay, So if we look at the fan out command, we have a few options. We have this BGA auto router. Now this is used when you have BGA components. It basically tries to fan out the BGA. It tries to get all the signals out from under the BGA to traces on whatever layers are available so that it's easier to connect to them.
Just to let you know, there's somebody's asking which design you're using. This is one of the example files that come with Eagle. It's called by TI. It's called a Launchpad, and
Hmm.
it's on their examples folder. Okay, so you could follow along if you wanted to. It actually does come with. Somebody's asking us to send it to them. I just want to let them know it's there.
It's there, yeah.
It's already there. So if you wanted to follow along, yes, go to expand the projects folder from the control panel and expand the examples.
Yep, and it'll be there. So in this video, we won't be showing how the BGA auto router works. There's actually let's show it. Let's show it. Change my mind. I'll do it with the example that comes with Eagle so you guys can see it.
I thought you were going to break out maybe all the grounds or something like that.
I'm still going to do that too, but since I
Okay.
started with the BGA auto router, okay. So now let me make sure all the layers are on. There we go. That way we can see other stuff to connect. So what you'll do is you'll click here on the fan out command. You'll click on the BGA auto router. Now what you're going to see is that certain components have been defined as BGAs. Okay, so you want to make sure that you have whatever BGAs that you want to work with, those have been defined. And if we look at the properties of this component, or do I still, oh, no, hold up. Select. If you go to inspector, you can see it has several attributes, and that lets Eagle know that it's a BGA. Okay, and these values specify where you want the breakout to be. So we'll go over here, BGA fan out. I can edit it. I can specify signals. I can have micro vias enabled, what layers are going to cross through, all that. And actually this excludes layers is what this does. So I'll click OK. And if I just click OK, you'll see that it'll start. It'll run it. And basically, it uses the top router as its foundation. But what it's going to do is it's going to break out the design, that component, so that all the nets are accessible from outside the part. So you can see here, we get all these traces coming out, being able to access the internal signals. And that happens even on the bottom layer. It just takes the wire out to the end. And this is actually, it may seem trivial, but in very high pin count components, there's an entire kind of subfield of study of BGA breakout. So it's an extremely sophisticated concept and one that's difficult to get right. But as you can see, we have access to all of the connection points now, thanks to the fan out, the BGA fan out algorithm. Now, one thing that's interesting to note is that that's the BGA auto router based on our old auto router on the top router. But these two tools, the fan out device and fan out signal, use a new set of tools. So if I pick fan out device here, it's going to basically do the same thing that the BGA auto router did. It may not get as far though, because it isn't optimized to do micro vias. But let's try it and let's see what it does. It's going to bonk at me. That's what it does. Let me put allow violations. Oh, see, it tried. It tried to get a few in. Now, why did I pick that option to allow violations? Basically, it allows you to see what the fan out tool tried to do, and if it violated a rule or something, you're gonna see, why it didn't put it before. So you can see these pads are all really big, and that's why it can't fan out normally, because there would be so many violations. So that will let you know, hey, I probably need to adjust my design rules or see if I can get smaller drills. So that makes it a useful feature. to for a moment allow violations and see why it wasn't able to fan out the component. So I'm going to go ahead and undo that. Now let's go ahead now and show a couple of things here with fan out device, and we're going to do it on this component right here. So if you notice, for fan out, you have two options. You can fan them outside of the part, or towards the inside of the part, or alternate. Those are your three options here. So let's try towards the part on the outside. And I'm going to take off the allow violations part, and I'm going to click on this component. You're going to see that wherever it might have run into a violation, it won't put the via. Okay. We can also do it the other way, towards the middle. Towards the middle, it'll probably work on all of them. And then finally, alternate. Now, what is this useful for? So obviously, as you guys know, using a ground plane allows you to benefit from EMI shielding, as well as having low impedance paths back to your power source. So it's in your best interest to be able to fan out, for example, your ground and power rails, have them go straight to the polygons, and that's going to give you the best power integrity in your board. So what we can do is, as I just showed you now, you can do it on device, but you can do it on a signal as well. So if I click signal, I'll put it here and just fan out outwards. Let's find a ground pad. If I click it, what you're going to see is it's going to take a little bit, but all of the ground pads, or most of them, will get fanned out, as you can see, everywhere on the design. And this is one of the old important use cases of the Autorouter. Before this feature, the only way to get something like this was running the Autorouter and specifying to only run on your ground nets. Okay, so it does need some cleanup. Like something like this, you would definitely want to clean it up. But in general, everything is fanned out and ready to continue. You're ready to continue on in your design. So this is something that's very powerful. Now, the Autorouter, as Ed was mentioning, isn't just the GUI that we showed over here. Okay, I mean, you can do everything through. You can hit select and just have it route, you know. And just have it route specific air wires. You can do it that way. Just start selecting them. Or in the command line, you can type auto and then specify what nets you want it to have auto routed. So for example, if I want reset to be auto routed, I hit enter, I hit continue, start, and you'll see that it will just do that. And it'll say it completed, you know, quickly, because it was only having to route that reset line. Okay, but you can put in a list all separated by spaces to route specific nets. You can also tell it to route everything but, and the way you do that is auto, exclamation mark, and then the different nets separated by spaces. So there's a lot of power in the command line utility of the Autorouter. So I'll say all in job with that. You can see it routed that reset line that I wanted. So if we look, you can go to help, general, just search for auto, and then right here, and you'll see the different parameters that you can use. The BGA, you can load and save a configuration, how you can enter specific nets to route. Okay, any questions? This is basically what we wanted to cover today.
We only had we only had one, and basically it was a comment. I think is when you did the route, it said some pins were empty, left without connections on BGA.
Mm-hmm. Yeah, some things will be, the BGA Autorouter, like the Autorouter in general, will do as much as it can. If it cannot find a way to get something routed, it simply won't, because the auto router is a slave to the design rules and your net classes. It is bound by those. So in that sense, that's kind of the leash
It
that's on
won't
the dog.
violate that. Yeah, you just will not violate it.
You know,
It will stick to it.
so if the DRC rules would be violated by routing a certain way, it simply won't do it. So you'll see that it'll leave it unrouted.
Exactly. Did we cover net classes? Yeah.
We did not cover net classes because this was the auto router webinar, but we can show it briefly.
Yeah, I just wanted to bring up the net classes because the auto router, in addition to respecting your DRC criteria, net classes will overwrite the criteria defined on DRC when they are
Larger.
specified. Yeah, when they're larger and specified to a particular signal.
Correct. Remember that net classes and the DRC are always competing with each other. Whichever one is stricter, that's the one that's going to be obeyed.
That one wins. Yeah.
So basically, whichever one is larger, because when you're looking at minimums, the largest of the minimums, that's the one that prevails.
So first of all, the net classes when you name a net class, don't name it the name of the signal because that does not create the association. Okay. So net classes, you have three criteria you could assign. You could assign it a width, a drill size for the vias, and what clearance you want it to keep from other signals in that same area. So what you do is that you create the net class, you give it a name, then go to the properties of the signal on the board layout, or you could go on this in the schematic, go to the properties of the net and assign that class to it. So at the bottom of the properties of the net, there's gonna be a class section in that property dialog box, and that's where you assign it this class. Okay. So don't because we've had some instances that they'll call the class ground, assuming that it will automatically connect to all your grounds, and that's not what's going to happen.
Yeah.
So it's best to create a class called power, and then now you could assign that to your grounds and VCCs, VDDs, and everything else. So you just create the class and then assign it to it. Okay. So are we? I guess we're done with the presentation and all the information we wanted to cover. As always, Jorge does a fabulous job. And this is the TA Launchpad, as we said earlier, which is in the examples folder of Eagle. So you could take into use what we've covered today and yes, recreate it, as well as this design that he's using here. This is also on the examples folder under the BGA. So everything that was covered today was a part of our examples as well. Okay, so somebody's actually asking if we could just do a webinar only on BGAs in the future. So
Yeah.
it's actually a very interesting topic. Maybe we could ask one of our expert elites to join us, which she is the BGA queen.
Hey, Rachel.
Yeah, she does a fantastic job of those. So we're on the Q&A session. If anybody has any questions on what we have covered today, please let us know. Jorge and I will do our best. Jorge will give you the right answer. I'll wing it. But I'll give it my best shot. See if we have any. I have my icon over here is bouncing around. Not sure what's going on there. No. Okay, this is something else. Okay. When you're on a Mac, when you get alerts, things start bouncing all over your screen. so okay. So I don't see any questions on our YouTube channel. Thanks for the conversation was actually really good on YouTube. On the chat, we only had one here. Somebody was saying, how about the different thickness for I guess for power planes?
Well, different copper thicknesses, like 2 ounce versus 1 ounce and all that.
I guess, yeah.
If
How
it's
about different thickness for PWR? He puts here, Fox.
so that would have to be discussed with the board manufacturer. I've never seen a manufacturer do multiple copper weights on the same side of a board.
Correct.
So that maybe he's not asking that, but remember that a polygon being basically a sheet of copper, the width that you assign it isn't really critical. Basically, there's an inverse relationship between width and resolution. The lower your width, the more resolution in which the polygon is drawn. So our typical recommendation for the polygons is use the biggest width you can get away with. That way you generate the smallest amount of data. One other thing I wanted to add, and hopefully that's clear from this webinar, is that the auto router is not, is not a silver bullet. It's a tool for the designer to leverage when it makes sense to leverage it. A lot of people are frustrated with auto routers because they see that it doesn't do as good a job as they would do or as they would want it to do. And the reality is that if auto routers were better than humans, then a lot of humans would be out of work. So, so keep that in mind.
Hey Jorge, this is a little story before we end. I was at a trade show and a professor addressed me. Actually, just happened more than once. He said, "Can we give them a version of Eagle without the auto for their students?"
I mean, you can tell. You can. It's very easy to tell when someone just let the auto go to town. So
It's a great tool, and don't get me wrong, we're not knocking it because it's extremely powerful, and there was a lot of things considered to actually implement into that algorithm, and it does a fabulous job. It's just always consider trying to do your manual routing. You're going to get a much nicer looking board, commonly aesthetically correct. Also lets you, when you go back to troubleshooting, you're in much better control of what's going on than if you were just having the auto router go at it. We understand that the auto router is tempting, get get the project done faster, but there's just so many factors to take into consideration. Okay, so just use it as part of the tool, not the tool. Okay,
yeah.
it's that really cool wrench in that toolbox. Yes, but every now and then you got to use the other wrench as well,
Hmm.
which is our manual routing tools, and our manual routing tools have improved immensely with obstacle avoidance, push and shove, and all the other stuff that we've added to it, that the team has added to it. Well, everybody, thank you for being part of the class. Thank you for attending our webinar. We're just about to be posting, most probably this week, by next week, our series for August. Also, if you're anywhere in the Portland area, you could always, I've sent our email almost everywhere, but if you want to find out information about the up and coming Fusion Academy, it's going to be in Portland. So there's going to be quite a bit of fusion classes for there, and there's going to be some classes in which we will demonstrate a little bit about the bidirectional capabilities and functionalities between Eagle and Fusion 360. Those of you that don't know Fusion 360, it's an Autodesk mechanical CAD tool, which is kind of cloud based, even though a lot of it is installed locally as well. Thanks, everybody. And I don't see any other questions. Oh, Lourdes is our producer, is putting some information there in case you want to contact us. Everybody have a great day. And thanks again.
Bye,
Appreciate it.
everyone. Take care.
Thanks, everybody. Bye now.